Babak, thank you for taking the time. Welcome to Stories in AI.
Thank you. Thank you.
How are you today?
Great. Recovering from a little bit of a flu, but I'm fine. Thank you.
I know. I'm glad you're back. I'm glad we could actually do this. And, why don't we have about, I don't know, roughly about 40, 45 minutes. So why don't we get started with talking about you? Tell us your story, your background, how you and why you got into AI, if you will.
Sure. I got into AI in the 80s. And it was, I take things like step by step. And back then I was trying to figure out how computers work. And there was a moment in time when I felt like I did. And at that point, a friend of mine challenged me to try to figure out how the brain works, which set me off on this never-ending quest, I think. From there, I actually got interested into how evolution and life itself kind of works, how life could end up building machinery as complex and fascinating as the brain. So that's my story as to how I actually got into it. In the late 80s, there was a lot of attention on AI. We were going through an AI spring. I caught the tail end of that when I was doing my PhD in Japan. Japan had this 5-year huge investment in AI back then. Then we hit a winter. We've come out of that winter. It's spring again, but it feels like we might actually be going into another winter, unfortunately, soon. But that's how it is with AI. It's springs and winters in succession. I think partly because that's the nature of AI.
It's kind of like crypto for that thing too. You have the 4-year halving cycle, and everyone exuberates, and then boom, it just crashes down and then gets back in, right? And AI as an evolving, dynamically changing space as well, it's very true that you have to have those, winters and springs so that we can see all sides of it and grow through it, right? So I think that's important. Now, beyond your modesty, you're also a published scholar in the fields of artificial life, agent-oriented software engineering, and distributed AI. What are some of the lessons there? I mean, what did you learn out of those? Are like really broad, big, large topics, right? And then here you are, a successful entrepreneur, now CTO of AI at Cognizant. What did you learn in those explorations, if you will?
There's a point in time when you start wanting to, at least for me, it was that I wanted the world to actually see and feel the power of what we see in the lab and what AI can do. And so then you turn your attention to how you can actually make it practical and impact more and more people. It was in the late 90s when I was challenged with, applying agent-oriented software engineering to natural language interactions. And I felt like that was, at the time, I thought, wow, that's a huge deal. But that challenge led into, inventing the precursor to Siri, and a lot of the technology and the team actually ended up starting Siri. That's the point at which I think it triggered this renewed attention to AI, because an interface is how we today interact with technology. And if the interface itself gives you a sense of, expecting intelligence, I think then you start touching it in a lot of places, and that expectation is a self-fulfilling prophecy. Now you need to make it smarter and so forth. That combined, of course, with breakthroughs in deep learning, and that opened up a lot of doors to the story. I mean, as an entrepreneur, my first few slides were about what is AI, and these days that's kind of like a laughable thing. You don't start your presentation with what is AI, which I think is sad, because it feels like everybody thinks they know what AI is, and often it leads to disappointment, because when you actually do get into describing the technology you're bringing to the table and what are the bounds of what you should expect from it, people usually are disappointed. It falls short. And I've said this before, AI is not even compared to human intelligence, not even to all of humanity's intelligence. It's this magical oracle that can tell the future and is always right. I mean, if you're comparing to that, we'll always get it wrong. So I'm not sure if I answered the question, but that's kind of some of my experience.
No, that's awesome. Let me ask you about, like, so if that is not AI, if it's not the magical oracle for the audience, what is AI? How would you describe it?
Yeah, I mean, I take a very practical, pragmatic approach to my definition. AI covers what programming leaves out. So you, as a programmer, as a software engineer, you can design something. Think of all the various nooks and crannies. It's like designing a building. Like, you know exactly where you want to set what, and how you design it and for what utility and so forth. And that's the design. It's when that design does not scale or falls short that you can defer to these meta algorithms that can cover the remainder. So they can actually figure out for you and on your behalf, extended into the future, responses from your software that you have not a priori kind of designed into it. So that's one definition. How do we do that? It's a bag of tricks. It literally is today a bag of tricks. There's no one size fits all. You can't go to a website and download AI. There is no such thing. And various different practitioners use different approaches. Even within neural networks, there are various different approaches to deep learning, various different architectures for deep learning that are used depending on the use case. There are other search methodologies that are considered to be AI. They can be used. They can be used as hybrid. So there's some actually level of engineering, surprisingly, that goes into building AI-based systems as well. So currently, at least, the state of the art is that an AI system is an engineered system that does have elements of machine learning and adaptivity that kind of scales into the future beyond what we can design.
That is so awesome. That's a good way to say it. I think it was that, I don't know whether it was still during the Dartmouth conference, but right after that, there was this definition of AI. AI is but a bag of tricks with a bag of problems, right? So it's a bag of tools for a bag of problems. That's and it's true. Because there's no one size fit all, which is a huge part. And I like how you said it. You brought it back in saying, look, AI or machine learning, or forget machine learning, AI as a broad field, or systems that are delivering that artificially intelligent outcomes are engineered systems. They have to be thought about that. Now, before we go into a little bit of that and going into how organizations are scaling AI, let's talk about your evolutionary AI theory. What is evolutionary AI, and what is the evolution of evolutionary AI?
Yes, so evolutionary computation has been around since the advent of modern computing. In fact, in some ways, it can be attributed to Alan Turing, who in fact also came up with neural networks, or the concept, and also defined AI. So we owe a lot to that guy. He was amazing. But essentially, just like neural networks are caricatures of abstractions for how we think the brain works, evolutionary computation is a caricature abstraction of how we think evolution and nature operates. And they're related not just because, the brain evolved, so it can create these very, very complex solutions to problems, but also because it's very, very efficient. The most important property of an evolutionary system is the fact that it operates on a population. So when we engineer an AI system or a neural network, for example, we are dealing with a single sort of representation, a single neural network, and we keep tweaking it until we get it right. In an evolutionary system, we're dealing with a population of candidate solutions. And, we're tweaking all of them in some ways at the same time. And with each generation, we're hoping that members in that population are getting closer to the acceptable criteria that we have for our ultimate solution. Why is the fact that we're using a population so significant? It's because the population gives us a sense of the terrain we're searching on. So imagine if our ultimate solution is, let's say, a peak in a rough terrain. If all we're doing is taking one candidate solution, one climber, and trying to tweak it until it gets to a peak, we might actually be at a foot of a hill. And so the best of our algorithms will ultimately lead us to, the peak of a hill and not the highest peak. But if we actually have a population, through some form of communication, we can actually get a sense of what that terrain looks like, and therefore where do we spend the most time searching. And so we get a better solution that way. These approaches have some very, very interesting properties. Evolutionary computation is agnostic to what it's actually optimizing. So you can actually use it with neural networks. You can actually optimize neural networks themselves. So work well with other AI approaches. They are, as I said, very, very efficient. So when you have a very, very large search space, rugged search space where there are a lot of like local optima, they do well. And they do well against multiple objectives. Why is that important? Typically, we're not solving for a single objective. We're not solving for a single outcome. Think, revenue. If all we were doing was solving for revenue, we would just, sell everything, at the cheapest possible and make a lot of revenue. But then, what about the cost, right? We're usually balancing multiple outcomes at the same time. It could be revenue versus cost. It could be reducing the impact of the pandemic versus the economic impact of the pandemic. Could be all sorts of things. Getting people discharged from a hospital but discharged healthy versus right. So evolutionary computation is very good at finding the best balance of multiple outcomes. And so it's good for these types of practical problems.
It's just very real life, if you will, right? So it's as real life and evolutionary as it comes to. There's a few things that come to my mind from drawing paddles or maybe trying to connect concepts, and you can shoot me down saying that doesn't make any sense. One is is this more the class of problems you can solve with this? One, you mentioned the characteristic of multiple outcomes, optimizing for multiple outcomes, right? Which means by definition, one machine learning model, one algorithm may not be able to give you, or will not be able to, I can actually say, right? Unless the outcomes are just diagonally opposite, right? So that's one. So so this is about finding the unknown unknowns. So by definition, does it only belong to a certain class of problems that it's going to be useful for? Or if you're just optimizing for click-through rate, is it an overkill to do evolutionary algorithms?
No, it's not. In fact, we spun off a company out of my last startup to do exactly that. So it Evolve.ai, what they do is they essentially evolve websites. So if you think, as I said, evolutionary computation is agnostic to the individual representation, and that representation could be a website. And if you think of the website itself as click-through or conversion rate or dollars spent, time spent, those are things that might actually be opposed to each other as well, and you want to get the best outcome. Then what you do is you create a population of designs for the same page, and you actually allow the system start tweaking it within bounds, within acceptable bounds. Let's say you don't want it to mess around with your brand identity or whatever, you can do that. But then, what hero image should I use? What kind of font? I have like 10 different titles for the page I can choose from. Which one should I go with? Below fold, above fold. There's so many permutations that suddenly your search space is very, very large and difficult to traverse. And these changes are related with one another. Changing the hero image versus changing the placement might be kind of related variables. So you can't just change one expecting that the other doesn't have any impact, staying constant. And so then you feed that in real time to your users. It's like A/B testing, but it's like AI testing. It's like A/B testing to the nth, right?
AZ testing, yeah.
AZ testing. And so then, as you get statistically significant feedback on the various different permutations, evolutionary computation allows you to get to the best pages that hit the best sets of criteria the fastest. So you don't have to actually try out all like 10 million different permutations. Maybe only 50, 60 will get you to a much bigger hike in your conversion rate, for example.
Got it. Oh, that's interesting. So the other thing that the actual evolutionary process could either be, and I'm assuming initially was more rules based, and then now you can use approaches like reinforcement learning and stuff like that to really optimize the path as well. Do I understand
you
that?
You could do that as well, yes. So originally, the original evolutionary algorithm was genetic algorithms, and hopefully many in your audience have dabbled in that. They're bit sets and very, very simplistic reproductive operators and so forth. They work quite well. But representations since then have been, for example, rule-based representations are quite unique because they're explainable. So the ultimate system that you generate is human readable. So that's amazing. Yes, it could be, rules to define how to set up your website, for example. It could be the architecture of a neural network, or the loss function, or activation function, or all of them together, hyperparameters, and you're evolving that. So that's one of the powerful aspects of evolutionary computation is it being able to do that. Now, to your point, though, it's interesting because we know that in certain use cases, you could have what we call lifetime learning. So an individual in your population could readjust, for example, using reinforcement learning, its behavior through its lifetime. And some of the meta algorithm for that behavior could be passed down to future generations. So yes, there are a number of approaches now that improve on the original genetic algorithm in that manner.
Yeah, it is pretty fascinating, and we could keep talking about this forever because for me at least, like I only recently started getting more and more familiarized with the concept, and that's why I had all these questions. But I can't help but draw parallels between what the AutoML world is doing right now. What you're really trying to do in AutoML is find the best algorithm to solve your problem, given a particular data structure and an outcome that you're expecting for. In a way, that is an auto-evolutionary system, even though it doesn't really meet all the other criteria that you talked about, right? And then yesterday I was talking to fellow neighbor and dear friend Doug Linnett of the Psych project, and we were talking about origins of symbolic AI and how and he talks about the Psych project, which is probably the oldest AI project in the world today. They have about 15 million rules for common logic that is coded in the system, and most of what they do for businesses right now is map the operators on the rules to actual domain specific things. And he's like, you'll be so surprised, and they were pleasantly surprised how adaptable it is in terms of trying to take that and apply it to one domain, to another domain, to another domain. It's kind of like an evolutionary system wherein it is the method that is critical, right? And the content itself can actually take different forms. And you still have the best outcome. It's fascinating. We could keep talking about it forever.
Yeah, it's really amazing. And yes, I mean, talking about AutoML, that evolutionary computation is very, very good at AutoML. Talking about rule-based systems like Psych, yes, I mean, even there you can think of that adaptation happening using evolutionary computation as well. I mean, I haven't talked to Doug, so that might be an interesting discussion there. But that's very true. At a certain level, I think having an open mind and taking from our bag of tricks and mixing and matching depending on the use case will actually result in some fascinating solutions.
Awesome. No, this is great, Babak. Now let's get to the AI in organizations today, right? So it's still AI or any kind of building AI systems, maintaining it, generating value from it, right? What's the state of the market today from your vantage point, right? I see all over successes on one side and a lot of failures everywhere else, right? And there are some patterns that you can see. But what do you see in about value realization, adoption, and actual use of AI in enterprises?
Yeah, a lot of what's happening in enterprises today would not quite be considered AI. A lot of data science and statistical model building and so forth takes place that is relabeled as AI and is really truly not quite AI. So that aside, much attention is paid to areas where, for example, deep learning does quite well. So if it comes to image classification, unstructured text classification and so forth, there are areas where AI has successfully been deployed and used. So that's clearly there. There's a lot of investment in data science teams and even AI teams in places where it would surprise you. Like, you wouldn't expect to actually be talking about the latest and greatest and I don't know, deep learning with folks in a company that doesn't seem to be in that area. But it points at the fact that there is a realization that this could be IP in the future for these companies because they own the domain expertise. And I think we're starting to move from, the data is my IP to, the model and the AI system that I build on that data is my IP. For some of the folks that are kind of front runners in that area. Now, it's still in its infancy, though. Oftentimes, AI is confined to research teams, and it's very difficult to move stuff out of research, even if it's a successful project. It's that chasm for these large companies to cross is very, very difficult. So that's part of it. There is the flip side where the line of business is actually interested in solving a problem and is looking at using AI, very, very practical oriented, short-term focused. And often what they're looking for is turnkey. So a lot of companies, a lot of startups out there are succeeding when they build these turnkey solutions that apply to that niche, and they do well. But they don't have the capacity to actually and the patience to try things out and take their merry time to get to an AI enablement on the line of business. So that's the flip side. And then there's these reliance between various different aspects of a company. The line of business typically doesn't own the data lake, for example. And then when you go to the data lake, they're not collecting the data the line of business would be using for that particular use case. And the data is often in a mess. So a lot of investment goes into let's build our data lake without actually paying attention to what the ultimate AI use case might look like.
I like to actually, back almost a decade ago, it was quite easy. I used to run the converged solutions business at Dell at that time. And Hadoop platforms or pre-built Hadoop systems was a big deal. It was pretty easy to sell, to be honest, right? All you have to tell them is there's a lot of data, you need to store it. What will you do with it? You'll figure it out later, right? Which is exactly how data lakes came about, right? It's like, hey, just store it. They'll figure it out. And now you store it and you're like, well, that's not exactly the data I needed.
Exactly right. Yeah. I run into that often where, now we have the data lake and all the data is in there and it's updated regularly and you can query it and so forth. And then here's our use case. And guess what? The use case requires data that your data lake does not have. And, so that I always say that, we're companies, everyone, including us, we're all on this AI journey. It would pay for us to actually envision what that end game AI enablement might look like for us and then work back from there. Rather than kind of deferring that and saying, oh, that's AI, it's too complex, or we're not ready for it. And just, as you mentioned, let's just get all the data in data lake. Well, yeah, but that might not be quite, the most efficient way to go about it.
Got it. No, and so you're so right. I think, outside of the technical talent problems and stuff, I think there are more fundamental challenges, which I also see the same thing when I talk to organizations, my past customers, where like there is all this, efforts going on across the enterprise, and some work, some is not, which by the way is the nature of the game for AI. It's rapid experimentation, learning, and learning fast, if you will. But I think you talked about the end game. What is the end game for the business with AI? How do I use this powerful technology, like any other technology, to define a future that I want to get into, right? So let me ask you the question on stories and experiences that you have with organizations. Give me some examples of organizations that have done it well. You may or may not want to name them, but you give me an example of, hey, here's what these people did, and here's why it's good, and some terrible examples, which obviously you don't want to name who. But give me some stories there to understand that.
Yeah. So a couple of stories here. So one very large credit card company, and these folks, identified the problem exactly where it was, which is, hey, for us to actually basically get our budgeting right, ultimately that's where the biggest and most critical decision making is happening. We need to map it back to, for example, all of our marketing campaigns and so forth individually. And that mapping back goes all the way down to single individual campaigns historically, how well they've done, what geography they were, how did we do them, all that kind of good stuff. And it required a huge leap across various different departments. You're talking like budget department versus marketing department versus, campaign on the ground, third party, marketing, all that. And, but that holistic view of ultimately all of this serves this purpose of my decision as to how much money I pay where and how I gauge how well I did in order to, in the future actually improve that. And right now that decision is being made, for example, annually, and being open to the fact that that decision could be made quarterly or even monthly and so forth. To me, that's the right approach. Now, yes, you then take baby steps towards it, but your end game envisioning what this might look like, I think they were doing the right thing, the right people in the room, looking at it. The wrong way of doing it, I mean, there are many, many different examples, but I'll just give you some anecdotes. You know what? Give me the insights, and I know how to make the decision. That's a bad starting point right there. And the reason for that is, do you really need yet another chart to look at to make a bad decision that you're never being held accountable for anyway? So you haven't really, and it's less about being held accountable. It's more about actually covering the entire loop of decision was made. We looked at the consequences. This is what we got. Maybe we should now make some modifications and changes, and being opening to that. In one case, if I were not in the room, I would not believe this. But someone just turned to me and said, what if we built this AI system and it tells us that what we're doing right now is perfectly good already? So that is, to me,
I've had experiences where I don't like this result, what it's showing me, so this should be wrong. This must be wrong.
Exactly. You get that too. I mean, we as humans, we're sometimes, very irrational when it comes to these sorts of things. That's right. One other area I would point at is data, the data requirement that is assumed. So you talk to people and you describe how the AI system might be used, and they turn to you and say, oh, I don't have enough data. I need much, much more data. And there are a number of issues with this. What the data you already have may be sufficient. So let's not discount that. It may already be sufficient. Secondly, when you actually dig deeper and ask them, what do you mean by I don't have enough data? You realize that what they mean isn't more instances of the data, which is what you would need, but more features on the data. I need to get more, from third party. I got to get weather data. I got to get like geo-specific, photos from, drones. And guess what? That's not going to solve your problem. It's actually going to make it harder, much, much, much harder. And so, I think these are some wrong notions that need to be corrected and will be corrected through time, hopefully.
Sounds good. No, what you mentioned at the beginning of the show, looks like we are entering we might enter another winter. Explain that thought.
Yeah, so AI brings with it this very, very high expectation. And my sense is that when the expectation gets disproportionately high, people start not realizing the ROI in their investments in what they expected, not getting back the ROI. And I think some of that is happening right now. I more and more I'm in meetings where people are like, well, AI isn't even possible anyway. And if you're talking about machine learning, we have a good data science team. And to me, that's kind of boxing AI down to its bare essential, making it this like niche, tool that's just occasionally used, and it misses the point entirely. And I think these are signs of us, getting past that hype cycle. There's going to be more. I see more and more like GPT-3 related startups. GPT-3 is amazing, fascinating work, but it is at the end of the day, a distillation of what's on the internet. It's
the world's fastest autocomplete, the most expensive.
It's the most expensive autocomplete. There's some fascinating, interesting use cases. I would caution people not to. There is a risk in using it because oftentimes it can, result in very weird results. And it's another example of very high expectation, because if you cherry pick GPT-3 results, they look out of this world impressive. But when you actually rely on GPT-3 type systems too much, then that can disappoint. And another example of not getting your ROI.
It's back to that data comment, right? Where the fact that when you have a system that is trained with absolutely no control on the quality of data that's being used to train it, right? Because it's everything it's called through the internet and learn everything that it could.
Right.
You have to expect. So it's not enterprise grade, but who knows, right? Somebody will figure out a good way to use that. Like the Copilot for autocompletes on coding, perfect, right? That's domain trained just with GitHub open source code. I'm like, I believe it. I'll probably try it.
I would use that. Yeah, no, absolutely. And we've played around with it. The fact is that, again, when it came out, it came out and got coverage as if, it will write your code. It won't write your code. So for me, when I write code and I go to, I don't know, Stack Overflow, whatever, for that piece of code that I don't remember, or that API call, this is perfect. It's awesome. It will help me. But don't expect it to write your code or replace your coders. And that mismatch in expectation is what I think we should be aware of.
GPT-3 or the OpenAI Copilot, Autopilot is just, it's basically just your Stack Overflow on your Vim editor, basically.
Yeah, exactly.
That's about it, right? So
that's right.
Anyways,
that's right.
So Babak, what is the future of AI? Give us a glimpse into what you're seeing into the future. We covered a lot of things, but bring it home for me.
Yeah, my hope is that AI will impact the way we make decisions. Because ultimately, think about it. That's ultimately where we need AI, not to give us more information, but to help us use information in order to make decisions. And that would be in our personal lives and in our business lives. And it could be hugely disruptive. One example I use is, we organize our companies in a manner because as humans, we are limited in our decision making. And so, because we're very good at, for example, single objective decision making, we have a department for, finance, and the sole objective is saving money. Whereas, the department for, sales, sole objective is revenue. Whereas the company has a dual objective, a balance of the two, right? So even at that level, even at the executive level, for the company, the decision maker can be impacted and improved using AI-based systems. And so I think my hope is that we will get to a point where a lot of our decision-making issues can be solved. A unexpected hurdle there is, the attribution of responsibility. It's not about the quality of the decision making that your AI can help you with. It's about what if it gets it wrong, and when it gets it wrong, who can I blame? As long as we have humans there, we can defer the responsibility to define things like ethics, things like right, because that deferral comes at a cost. When a mistake is made, we hold someone or an organization responsible, and we punish them, and we feel okay. But how long can we defer that? And how big can these mistakes be? If we have an AI-based system, we can reduce them. We can't eliminate them. But then we don't have a party to blame. And obviously, as an AI practitioner, you and I don't want to be that party, right? So that is, I think, will inhibit us from getting there. A lot of the talk about responsible AI, ethics in AI, is about that. If an ethical mistake is made because I have this autonomous system making decisions, who do I go to? Who do I throw to jail? And you're taking that away from me. So I think that's a very important piece. I think the bigger picture from my perspective, where will AI end? What is the future of AI? My hope is that we can get systems that can, from very simple first principles, be adaptive enough to solve problems in the future without requiring tweaks and changes. And that might sound simple. It's very, very difficult, and people have written papers on why it's impossible. But I think that's a quest that as AI scientists and practitioners we should be on. Be very interesting.
That is awesome, Babak. This was awesome. What, according to you, the flip of that question, is one of the most important work that's happening in the field today in AI?
A lot of work is happening in the field today. Obviously, you want to pay attention to what's happening in the deep learning world. It's amazing, fascinating, transformer-based architectures. We've only scratched the surface of what they can do. They seem to do quite well even on images. We do want to start applying a lot of this technology to video and sound, and then a hybrid, like a mix of all of those. I think that would be amazing. And in the process, I think we'll use up half the energy that we produce in the world. But I think that's one very interesting area. The application to reinforcement learning, I kind of sometimes think we're going about it the wrong way when it comes to reinforcement learning, because reinforcement learning is exactly about encountering new problems that you've never encountered before and being able to, in an agile manner, kind of resolve them. Whereas I think the track we're taking is mostly about, let's play Go or chess billions of times, trillions of times until we learn how to play it. And I think that's kind of counter to that approach. Having said this, there are a number of very interesting hybrid approaches, tree search, so forth, that are interesting. My own area of interest remains artificial life, where I'm looking at population-based approaches where the members of the population only solve through survival and competition and collaboration, which is emergent. They actually solve problems. To me, that's a fascinating, interesting area as well.
That's awesome. I got two quick rapid fire questions for you. Artificial general intelligence, AGI, do you believe in it? Do you fear it? Are we going to see it in our lifetime?
In some ways, everybody in AI is on a quest for AGI, and it does depend on how you look at it and how you define it. I don't think the way it's defined generally is possible. I think if AGI is defined as intelligence at the same level as human intelligence, it's got to be possible. Whether or not and how and when we're going to hit it, I think we are still quite some time away from that, and I think what we will find will disappoint, simply because our particular type of intelligence is configured specifically in a certain manner through evolution that is going to be very, very difficult to duplicate. Am I afraid of it? Not really. I mean, just throw in an off switch. Let's just remember that.
just put a kill switch in there. Awesome. Babak. Another question for you is, if you're a startup or an entrepreneur looking at the space right now, and there's a potential winter coming, but there's still a lot of potential and opportunities, what would you tell them? What advice do you have for them?
Yeah, with the winter coming, usually what we do and what we've done in the past is just not name it AI. Don't call it AI. Call it whatever name it has, that approach. If it has value and the timing is right, you will derive value from it. And you can do away with the confusion that this overused term AI is going to do to you. So, but don't give up though. I mean, I don't think just merely hitting, funding will go away on research, which is a huge, huge pity. And as has happened in the past. But we're much farther along with venture capitalism and startups for that kind of funding to go away. So I think that will carry on.
Awesome. Babak, one personal question: what's a favorite power practice of yours that you attribute to your success, your sanity, whatever?
I play a lot of soccer, and
That's awesome.
I'm fanatic about it a little bit. Hopefully, I'll be able to do more of that, but. One thing that I do is in the morning, no matter what and what time my first meeting is, I have to go for a quick walk out there, regardless of the weather and so forth. And that has helped me a lot.
Awesome. Babak, how can the viewers and listeners get in touch with you? Where can they find you on the internet?
I would say the best way to get in touch would be through LinkedIn. I do respond to LinkedIn inquiries and so forth typically. So please search me up on LinkedIn and I'd be happy to connect.
Awesome. Babak, this was fascinating. Thank you so much for spending the time today. And it was a blast.
Thank you so much. It was a pleasure talking to you, Ganesh.